Hello and welcome to another March Market Math movie production where you get to play the therapist and solve all of math's problems. Today, we will be working on lesson 2.4, graphing linear equations in standard form, which starts on page 70 in your math book. So turn there so we can get started. You'll remember from last lesson that we talked about slope-intercept form. Slope-intercept form is a line, and it's in y equals mx plus b, where m is the slope and b is the y-intercept. So this is the name of the equation when it's in that form. Today in this lesson we add another kind of form, another name, and this is standard form. So this is slope-intercept form. This is standard form. Standard form is ax plus by equals c. A, x, and c are all variables that stand for numbers. What we're going to be doing is we're going to be working with this and graphing this just like we did with slope-intercept form in the previous section. One more note is that in standard form, a and b cannot equal 0. So a does not equal 0 and b does not equal 0. Okay? So once again, standard form, ax plus by equals c. In slope-intercept form, y equals mx plus b. All right, so here's example number 1. In example number 1, you'll notice that we have standard form, ax plus by equals c, or 2x plus 3y equals negative 6. The directions want us to graph this. Okay? Step 1, in order to graph an equation that's in standard form is to put it in slope-intercept form. Okay? So we're going to rewrite this equation so that's in slope-intercept form. 2x plus 3y equals a negative 6. And to start this process of getting it to look like y equals mx plus b, I'm going to subtract 2x from both sides. And I'll be left with 3y equals negative 2x minus 6. And the reason why I put 2x in front of the negative 6 is so that it looks like mx minus b, or plus b in this case, plus a negative 6. But I'm still not in slope-intercept form because I have a 3 here. So just like we do in other equations, we're going to divide by 3. So divide this side by 3, and divide this by 3, and divide this by 3. I'm left with y equals negative 2 over 3x. That cannot be reduced anymore. But if you'll notice, negative 6 over 3 can be reduced. You can divide both of those by 3, and you will get minus 2 over 1. Okay? Divide by 3, and you'll get a negative 2 over 1, or just a negative 2. So now we're in slope-intercept form, which is what we want to do. And the next step is just to graph it. So now we know, we've done this before, we know how to graph this. Our y-intercept is at negative 2, so put a point at negative 2. And then our slope is up 2 over 3. Remember, rise over run. So we're going to go up 2 over 3. 1, 2, 3. Do it again, up 2 over 3. And then we can connect these points with a straight line. And now I've graphed the equation negative 2x plus 3y equals negative 6. That's standard form. I switched it into slope-intercept form because it's easier to graph, and here it is. Just like that. And I'm done. Okay, this one is one for you to try. This is in standard form. You have 1x, even though it's not there, plus 1y, even though it's not there, equals negative 2. So this is ax plus by equals c. You're going to graph this equation. Pause the video and unpause when you're ready for the answer. Alrighty, let's see what you did here. First thing you need to do is you need to get this into y equals mx plus b. So to do that, you need to subtract x from both sides to get y by itself. And you should be left with y equals negative x minus 2. Now you're in y equals mx plus b. So my y-intercept is negative 2, so I'm going to go to negative 2. And then I'm going to look at my slope, and I look at my slope, and there's a 1 there, even though it's not written. It's a negative 1 over 1. So there's a negative 1 here, and it's over 1. And so my slope is down 1 to the right 1. 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 Put your line, draw your arrows. And just like that, you've graphed that equation in slope-intercept form. All right, just for practice, here's another one. Pause the video, work it out, and see if you get the right answer. All right, what I would do is I would put this into slope-intercept form, which means subtracting both sides by 2x to get y by itself. And I'm left with y equals a negative 2x plus 5. That's a positive 5. My y-intercept is 5. My slope is a negative 2 over 1, so that means rise over 1. I'm going to go down 2 to the right 1, down 2 to the right 1, and connect it with a line. And I'm done. All right, before we go on to example number 2, let's just review real quick. An x-intercept is where a line crosses the x-axis, remember. And a y-intercept is where a line crosses the y-axis. All right, so let's look at the x-intercept of this particular blue line, and it's right here. And the x-intercept is, I know I just covered up the 2, but the x-intercept is 3. So ask yourself this question: what is the coordinates of this point? X is at 3, what is y at? You didn't go up or down any, so y is at 0. Okay, now let's look at our y-intercept down here. And it crosses the y-intercept at negative 4. Well, what's the x-coordinate? Did you go left or right any? No. And you went down 4, so the coordinate for the y-intercept is 0, negative 4. Why I point this out to you is because notice when you have the x-intercept, what does y equal? When you have the y-intercept, what does x equal? Okay? The x, when you're finding the x-intercept, y is always going to be 0. And when you're looking for the y-intercept, x is always going to be 0. Keep that in mind as we move on to example number 2. Here's example number 2, and example number 2 wants us to graph this, x plus 3y equals negative 3, but it wants us to use another method. It wants us to use intercepts. Now, could you put this in slope-intercept form and do it that way? Sure, but they're just giving you more than one way to skin a cat, and you might like this way better. Okay, so what you're going to be doing is you're going to find the x and the y-intercepts. You're going to let y equal 0 when you're going to find the x-intercept, and when you find the y-intercept, you're going to let x equal 0. So instead of talking about it, let's do that. I'm going to show you what I'm talking about here. Let's find the x-intercept. Okay, we're going to find the x-intercept first. And when we find the x-intercept, we want y to be 0. So let's rewrite our equation, x plus 3, but instead of y, because we want the x-intercept, let's let y be 0, okay? And then, let's solve for x. 3 times 0, this is pretty simple. 3 times 0 is 0, so that just leaves us with x equals negative 3. So our x-intercept is negative 3, or is at the point negative 3, 0. Once again, just real fast, when I solve for the x-intercept, I let y equal 0, and I plug that into my equation. So I put 0 in for y, and then I solve for x. 3 times 0 is 0. That leaves me with x equals -3, and that's my x-intercept. Now we have to do the same thing for y. For y, when we find the y-intercept, we're going to let x equal 0. So let's rewrite this, but this time x is going to be 0, and we're going to solve for y. Okay, we don't really need that 0, so it's just going to be 3y equals -3. And I don't say we need it because you could subtract 0 to the other side, and it's going to be -3 minus 0 is still going to be -3, right? So the 0 just kind of drops away, and we're left with 3y equals -3. I haven't solved for y yet. In order to solve for y, I need to divide by 3 and divide by 3. When I do that, I should get y equals a -1. So the y-intercept is -1, or it's at the point 0, -1. Remember, the y-intercept is always going to have an x-coordinate of 0. So here's what I have. Now it wants us to graph it. Okay? So we found that our x-intercept was at -3, at the point -3, 0. And we found that our y-intercept was at -1, or 0, -1. The only thing that I have left to do is to put these on a graph. So I'm going to put my x-intercept at -3, or -3, 0. And I'm going to put my y-intercept at -1, or 0, -1. Right there. And then I'm just going to connect those two with a straight line. And I've graphed this using, this method is called using the intercepts. You could put the original equation back into slope-intercept form and you would get the same exact line. No big deal. Either way, you'll get the same answer as long as you perform your operations correctly. All right, here's one I want you to try on your own, and I want you to use the intercepts method, right? So pause the video, solve this and graph it using intercepts, and then unpause it and we'll work through it together. Okay, I'm going to solve for the x-intercept first, and because I'm going to solve for the x-intercept first, do you remember what you let y equal? That's right, you let y equal 0. When we solve for x, 3 times 0 is going to be 0, so we're just left with x equals 6. So our x-intercept is going to be at the point 6, 0. And now let's solve for our y-intercept. When we solve for the y-intercept, x equals 0. That 0 kind of just goes away. And we're left with 3y equals 6. Divide by 3, divide by 3, you should get y equals 2. And our y-intercept is going to be at the point 0, 2. Okay, so now that I've found my two intercepts, all I have to do is graph them. My x-intercept was supposed to be at 6, 0, so I go over 6, up and down 0. And my y-intercept was going to be at 0, 2, so I go over, left or right, 0, and I go up 2 spaces. And I plot my point, and then the only thing that I have left to do is to connect them with a straight line. And again, forgive me for my curved line. Your line, of course, will be better because you'll be doing it on pen, and you'll be doing it with pencil and paper, and you will have a ruler to do so. So if you got this answer, congrats. I think you got it. Either way will get you where you want to go. Either doing it by putting it into the slope-intercept form or by solving for the intercepts themselves will get you where the destination where you want to go. Okay, so that leads me to the joke of the day. What do you call birds that stick together? The answer? Velcros. All right, guys, thanks for tuning in. I will see you next time. Remember that God loves you.